So these are the two bottles I've used to make this stove. The one on the left, I've cut it 4 inches from the base. Then there's another cut at 22 inches, and then I've welded the pipe on the top, which is 26 3/4, and that's a 5-inch pipe. I know it's only mild steel, but at the moment it's all I've got, and this is a tester. The other bottle, I have cut it at 8 inches. Different types of bottles. The scrap man dropped them off for me. Someone, he'd picked them up somewhere, and someone had actually welded a pipe between the two of them, drilled a hole in them and welded a pipe on. They must have been using them as compressor storage air tanks or something like that. Right, so on the side of that I've cut a 5-inch hole in, and that will be for the exhaust flue gases. And on the other side of that one there's a hole there, that will be the firebox hole, and it's 6 inches wide and 4 inches high. Right, so as I say, the bottles are cut. So that's the pieces all disassembled. There's the top with the pipe welded on. You've got the middle section, which will become the rocket stove body. You've got the bottom there that will become the firebox, and that will be the top of the rocket stove. The piece, the original bottom piece off the red bottle, I don't need that, so you can use that as a bird bath or something. So I'll just show you how this lot goes together now. This top section will sit on that bottle, and that will become the actual rocket stove internal. That needs a shroud around it and some insulation. Then that bottle will sit on top of that one there, and that will become the stove body. The flue wants to turn in a little there, so it's facing the back. So that's your the bottom, and your middle section, your pipe on there. I'll take the top section, just put that on the top. So that essentially is your rocket stove there now. I'm going to put a door on the front eventually with a glass viewing window. This is again, as I said, and it's an experimental one. It'll have air control in it, so and a glass air wash system. If this is successful, I will make a deeper firebox than that. I'll maybe make it a foot high so I can get plenty of timber in there, give me a longer burn. And the flue outlet on the back, that just needs a little box building to run the flue pipe off. So I'll get all this welded up now and we'll have a test burn. Right, I've welded the bottles together. It's all welded up. All I've done really is just tack it together, because this is just a test after all. There's a little hole in the top there that I'm just going to cover with that plate. And I just need to make some kind of little firebox thing there to accept the flue. Right, that's the bottle welded up, almost welded up. I made the little flue box on the back there. Naturally you'd have that as a removable plate so you could clean off inside there, but it was very late last night when I'd finished welding up that box. So I'm just going to sit the flue on there for this test burn. So that's the flue in place. got much of a flue. It's actually all I've got there, so I'm just going to try this. Yeah, it was late last night when I'd finished welding that thing on, that little box on, and sorting out the flue plate. And there's actually a part of this I haven't showed you yet, this stove. But last night I did a test. I just did a burn last night to burn the paint off the stove, and it burnt really well. But there is a panel underneath I didn't show you, which I needed to burn some paper in it last night and a few sticks to sort of see what adjustment and what height this plate and what gap it would need to have, because I didn't want the flames going straight up inside the rocket tube. I wanted the rocket to work a little bit. So I have to do a bit of work, shall we say. So I'm going to fire this up now. I think I've got the gap right. We'll see how it goes. I'm just going to see how long it takes for that burn to get relatively smokeless. In order to try and create a vortex in this chamber, I'm going to try the method that Catrophius has used on his, which is kind of a plate bent within the riser tube. Get the air spinning, but already it's almost clean and it's burning away there. I'll also introduce the secondary air feed. I will do introduce a secondary air on top of the plate that's on the inside. Feed it directly into the riser tube. A normal rocket takes 4 or 5 minutes to get enough heat into the riser to actually burn all the gases, so it'd be interesting to see what happens with this. The opening at the front there is too big for the riser, so the panel I cut out from the front, I'll just get that and I'll just wedge it on to just reduce the amount of air that's actually flowing in. I've not put much wood on, there's just a few sticks in there. You can see it inside that or not. That's what's happening with the plate, it's forcing the flames to go around the sides. This definitely needs some secondary air intake. All that's happening is there's too much getting up inside the riser tube. It's not got enough air in the riser tube to burn efficiently, so all it needs is secondary airflow into the riser, which is quite easy to do. It's reached about 400 degrees. It's not bad for the amount of fuel that's gone in it, not bad at all. from your riser, from your flue should I say. You can see the heat rising off that back fence, the shimmer. So the mods are to introduce secondary air into the riser tube, to create a vortex in the riser tube, to build a door for the front of that, and I think there you've got a pretty compact little rocket stove. Okay guys, I'll update this when I've made the changes and we'll see how much better it performs. Okay, thanks for subscribing, and if you like, any comments welcome. Bye for now.